Cool. Yeah, so there's this more traditional one, the 84 by 48 LCD. There's also, yeah, the other one that I mentioned, the high let go one, more or less the same. I'm going to be focusing on this one. The same should apply, just this one requires color data as well. The other one is kind of just on or off. Yeah, so section 6 is a good one, specifically for the 128 by 128. I forget the exact section number, but it's the pins section. And then the one we're most interested in are like the chip select pin, so CX, CSX. And then these pins should also be labeled here. So you have the chip select. It's a bad color to use. Chip select, you have A0. A0 on the data sheet will be something like C/D. It might also be D/C. The D just stands for data, the C for command. And those are just two different modes that you can have it in. And then we also have SDA, which is the actual data that we want to send to the screen. And then a clock, which is just going to be like a high-low, high-low, high-low signal. Yeah, and I'll talk about that a little bit as well. There's also an LED. This is for the backlight, I think. Yeah, there's also a reset, ground, and VCC. But the pin section should kind of talk about all these. So you have DC here, your chip select, RDX, I don't know if that's used, WRX again, DC. And there are a few ones that are connected on the LCD end itself. Yeah. Yeah, so the next section is, I think it was section 9. Yeah. So in section 9, it actually talks about like the clock signal and the data that you have to send it. There's two different modes. There's this like 3-line serial, then there's also a 4-line serial. I believe that we're using, or it's wired to use the 4-line, as the 3-line doesn't include this DCX pin, which is wired on the LCD. Right, that's the A0. So it seems like you can control it without A0, but we are using A0, so we're going to be in this 4-line serial mode. And this is pretty much just how the commands work. So if you've never used a device on SPI, which is the protocol that this uses, there is a chip select pin, CS, and this is how you determine which device is used. So if we, with the SPI protocol, or SPI, yeah, something like this. So we'll have one main device. In this case, the SPI main one is going to be the Arduino. And then you might have one or more devices connected. So in this case, there are like 3 devices, but you're probably just going to be using one. So you're going to like ignore these 2. And then this would be the LCD. And again, you have SCK, SDI. This is SDA. This is the same thing. SDO, I don't believe we have. I believe it also uses SDA for that, and then the chip select pin. So you can see that each device shares the clock line. This goes to all of them, all the devices that are connected. Same thing with SDI, and then also the same thing with SDO, but again, we don't use that one. And the only thing different is this chip select pin. Each device has its own chip select. So for the LCD, you're just going to be wiring, I believe it's these 4, with the exception being, instead of like having this like MISO pin for communication back, instead, this is going to be a another pin because it isn't exactly SPI. It's like a slightly modified one, but it's going to be like this DC one that then connects to your Arduino as well. So slightly modified SPI, but kind of the same. And then so with that, you can see we also have the chip select pin here. So in order to start a communication with it, you need to pull the chip select pin low. So that would be like a digital write 0. And then when you're not using it, you want to bring it high again. So when you want to start communication, you would do like a digital WR low to begin communication. And then you're going to start sending data. So this is where you're allowed to use the SPI library. I believe it's pins 10 to 13. These are the ones that have the specific functions for like SCL, SDA. But then DCX will have to be something that you wire. So there'll be slightly additional logic there. But you can see the clock, it just goes high, low, high, low, high, low. This will be done for you using the SPI library. You would just kind of say like SPI dot, don't quote me on this, but it would be something like SPI dot begin transaction, I think. All right, this is meta after the fact, Emerson, just clarifying that instead of SPI.begin transfer, it actually should just be SPI.transfer. And then you would send some data. I don't know, let's pretend it's hex 0F. And then it would manage this clock line. So it'll do the automatic high, low, and then it'll send the data 0x on the SDA pin. So it would look, if you were to send it 0x, 0F, it would look something like you would have SCL doing high, low, high, low, high, low, high, low. Try to get a little more precise than that. Four, 5, 6, 7, 8. Okay. So then at each rising edge, so when it goes from a 0 to a 1, oops, it'll expect a piece of data on SDA. So in this case, it's 0x0f in binary. So it would be 0 for the first 4 bytes, and then 1 for the next 4. So at this rising edge, it's a 0. This rising edge, 0, 0, 0. At this rising edge, 1, 1. Slightly overlap with the text, but hopefully you get the picture. 1 there again as well. And remember, this part is handled by the SPI library, which you are allowed to use. The tricky part comes with this DC, the data or command mode. And for that, I ask you to look at section 10. So this is also kind of just talking about some examples and the midway point of section 9, but we'll also get back to that in section 10. It should be here eventually. There we go. Okay. Are there any questions so far? Not, I'll continue. Yeah. So section 10 for this one is the commands that you can send it. And so which one did I want to talk about? Yeah, let's do display on and display off. So these all have their appropriate sections. So if we do 10.1.17, we can look at the data for the display off command that we send it. So a few things to note. DCX, the DC pin, should be a 0. And then you also have the WRX pin, the RDX pin. You want this to go from, I guess, low to high. And then RDX should be a 1. I don't think that these apply in our case. This might be a different protocol or different way of interacting with it, but we do not have the WRX or RDX pins on this. So mainly just focus on DCX, or sometimes it's just called DC, and then the data pins. So as the name implies, this turns the display off. There's also turning the display on, which I think is the next one. And so for this one, you need to send it the code in hex 28. So yeah, 00101000. And then when you send this command to it, again using something like SPI dot begin, something like that, you would then send it 0x28. We also have to make sure the data slash command section is pulled to the right pin or to the right value. So you'd want to do something like digital right. It's going to depend on what pin you have. So something like X, you're going to want to do low to make sure that this is a 0, assuming X is a DC pin. Yes, you want to make it low. You also want to do the chip select pin low. So whatever pin the chip select is, you want to do that low as well. So you do that low, you do DCX low, and then you begin the transaction. And then this should send the this code here to the LCD, and at which point it should turn off. This code might be different for the 48 by 84 traditional Nokia LCD, but it's going to be more or less the same procedure. You're going to have this DC pin, you're going to have some data that you need to send it to perform a certain action. But turning it on and off isn't all that useful. You probably want to know how to like write stuff to it. So there is, of course, a command for that as well. We go back up to the command section. There is, yeah, memory write. I believe this is the section that we want. We go to this section. This is where it gets fun. So with this, along with sending it the command itself, you also need to send data along with it. So you would first, let's see if I can bring that text back. So you would first do the same thing, bring chip select low, bring DCX, it depends. So at first you need to send this command, this first row, first row, sending it a 2C. So now instead of 28, it's going to be 2C. And this tells the device that we're going to be sending or setting color data or data to the LCD itself. So after you send that, which again, DC is low, we then need to make DC high. So you can do a dig W, whatever X to high. At which point then it expects us to send actual data. So this D765432110 will represent the first parameter or the first bit that we want to set to a color. So I believe this says memory range. Where does it start? Okay. So before this, remember when I did this, I also had to set, the X address. So again, this has kind of the same mode. You would issue this command and then give it an X address to start at, using a procedure similar to what I'm doing now. But then you would just set like an XY location to where the data would start writing. Yeah, so then yeah, after we send this initial command, we would send the first parameter, setting DC high, which is this step here, and then sending it bits of color data. This will automatically do, again, the high low for the clock, ugly, but it works. And then you would send the appropriate like D7, D6, D5, D4, D3, D2, D1, D0. And for what that exact data is, I think that's where we would go back to this section here. So there's a few different modes. There's a 12-bit per color mode. There is I want to say 16 and 18. 12, 16, 18, yes. And that's a mode, again, that you can use a command to set which mode it's in. I'm just going to talk about the 12-bit color mode. Honestly, that's probably all that you actually need. So yeah, we can see in this example, section 9.7.2, it's in the 12 bits per pixel. And so you can kind of see how it works. Again, like I mentioned, this clock select line goes low, meaning that the LCD is what you're going to be controlling. And then you can see also how the DC pin is set. So when you send this first command here, DC is a 0. And then, yeah, you set it low. And then you issue these commands using spi.begin transaction and send, I forget exactly what this is. I think it was 0x2c. But yeah, is this data? And then you pull DC to high, so you make it a 1 now. And then you start sending color data. So that's this would be, yeah, D7. D7 is going to be red, D6, again red, D5 and D4. These are also red. And then D3, D2, D1, D0 is going to be green. And then you're going to send 4 more bytes in the next transaction of the next 4 bits of blue. And then if you continue writing, it's going to be the pixel after that. So once you set the cursor location to some like XY value on the LCD, so if I set it like starting here, and then I set a certain color, it'll set that pixel. If I continue to send data, it will then set the pixel next to it. And then if I continue, the next pixel, and so on. And then I believe it wraps around to the next line. But I also think that that is also another thing that you can configure using these commands. So just make sure you have it in the mode that you expect it to be in. And then if you only want to set 1 pixel color, I'm not too sure what to do actually. I don't know if you want to send like 0, 0, 0, 0, or if there's another interaction that you need to do. But yeah, I'll leave that to the reader to determine. Maybe go with this mode because this is 2 distinct bits. But again, this is the 16-bit per pixel mode. So you would send, what is this? 5. Huh. Is that right? Yeah. 5 red, I guess 6 green. And then 5 blue. And that's kind of 2 distinct pieces of data, 3 if you account the command itself. So yeah, hopefully that makes sense. Hopefully that helps a little bit. I'll see if I can post this video on Discord. And if it's not good, guess I'll re-record it. But yeah, hopefully that answered a couple of questions. Okay, cool.